however, which is far less widely understood, differs in that it occurs only in framed walls or floors and breaches only one of the two membranes. A common example of this is a P-trap. Another common example of membrane penetrations are electrical boxes. Codes permit an opening for these boxes of up to a maximum of 16 square inches without protection. This presents a problem when the 16 square inch limit is exceeded with a larger box, a combination of multiple boxes within a single stud cavity, or boxes on opposing membranes. When these conditions are encountered, the boxes must be protected with fire-stop putty pads. Code language mandates that membrane penetrations shall be sealed as half of a symmetrical through penetration, but more often they are not sealed at all, which is a code violation. Perhaps one reason for this stems from the fact that Type X 5/8 inch fire-rated gypsum board is thought to be fireproof by itself, which is not entirely accurate. While most people understand that these walls are designed to prevent smoke and fire from spreading between compartments, it's far less understood how this works. Fire-rated gypsum board is only one part of a complete system composed of framing members, fasteners, fire tape, and mud. When erected properly, the stud cavity becomes an airspace that provides excellent thermal insulation, which is a key to the performance of these walls in a fire. The layer of gypsum board on the exposed or hot side of the wall is considered sacrificial and is not expected to survive the full hourly duration of a fire, provided that the last layer of the wallboard on the unexposed or cold side is fully intact at the end of the hourly duration. In a fire, as the layer of wallboard on the hot side fails, exposing the stud cavity, any unsealed membrane penetrations on the cold side instantly permit the products of combustion to be forced through the opening, breaching compartmentation. This is why it is just as important for membrane penetrations to be fire stopped as it is for through penetrations. Both through and membrane penetrations are examples of a single item being routed through one hole. Needless to say, grouped penetrations often share a single opening. A common example of this is where multiple conduits are racked together and routed through a large rectangular opening. This special condition can be sealed effectively, but requires care to ensure that the fire stop installation can handle the additional strain of such a large and complex opening. These openings are often designed with future capacity in mind and are frequently far larger than immediately necessary. Excessively large openings can complicate fire stopping and may require a reduction of the opening size before the fire stop itself can be addressed. Sometimes this is simply a matter of scabbing down a hole using layers of fire-rated gypsum wallboard or forming a dam and pouring fire stop mortar into the opening. While all openings must be sealed within the requirements of a given UL system, excessive annular spaces and grouped penetrations present an especially difficult problem because there are so few UL systems available for these conditions. When a UL system is not available, contact the fire stop manufacturer's technical service department for instruction prior to installation. The instructions will not only indicate how to restore the fire rating, but also how to deal with the multiple penetrants, the large opening size, and any other variables that need to be addressed. Fire stopping an opening without such instructions can lead to non-compliance and expose you to unnecessary liability. So it's always important to obtain an engineering judgment from the fire stop manufacturer for non-standard penetrations and follow the installation guidelines precisely. If structures were erected entirely from non-combustible building materials, such as concrete, gypsum, steel, and copper, then fire stop would be dramatically less complicated. The reality is, however, that we need fiberglass and foam rubber pipe insulation for acoustical and thermal benefit. Flexible protective plastic jacketing is needed for electrical cabling, and particularly in labs, plastic pipe is often the only piping material that can handle corrosive fluids like deionized water, acid waste, and certain bulk chemical process and supply lines. Each of these combustibles serve very important functions and are therefore unavoidable. Unavoidable or not, however, they are no less combustible. Non-combustible penetrations like steel pipe and conduit are difficult enough themselves to deal with, but can usually be handled simply with fire-stop sealant. Conversely, combustible penetrations present a much greater problem. Utility closets illustrate the point well because, in effect, what we are doing is stacking these compartments and adding openings in each floor, creating a chimney. If that weren't bad enough, we then load these openings with cable or fuel. And during a fire, the combustible materials are consumed, creating a gap in their absence that permits the passage of superheated gases, toxic smoke, flames, and heat. Needless to say, this seriously jeopardizes a building's compartmentation. So, how are combustible penetrations in a fire barrier restored to their original rating? By using fire-stop materials designed to expand with heat in a process called intumescence. This technology permits rapid expansion in the presence of heat so that voids created by the melting combustibles can be sealed by the intumescent material. This means that every combustible penetration, from the jacketing on a small wire to large diameter PVC pipe, must be filled in as it melts in order to preserve the fire barrier. The problem is that some combustibles, like 1-inch thick fiberglass pipe insulation, require very little intumescent expansion to adequately close the void, while others, like plastic pipe and cable bundles, represent a far greater fuel load and generally require more expansion to provide the same amount of protection. No discussion on fire stop can take place without first understanding this, which brings us to the heart of how to deal with any penetration. The most common mistake made is that fire-stop sealant is generally caulked around a penetration with little or no regard to the type of penetration being sealed. While a relatively small bead of fire-stop sealant may be adequate for a metallic pipe, smearing a thin film of caulk around a large plastic pipe or bundle of cables simply won't work. The point is that a prescribed minimum amount of intumescent material is needed to do the job, and this information must be known prior to installation to ensure adequate protection. So let's explore this process and see exactly what's required. Many installers mistakenly assume that simply having a UL logo on the tube offers adequate compliance. This misconception can be very dangerous. Each manufacturer of fire stop is required to test their products in a furnace at a third-party lab such as UL to determine if their products actually work in the presence of fire. When a test is successful, the lab issues documentation that permits an installer to use that material only in the application tested. This documentation becomes the evidence of compliance to an authority having jurisdiction. The problem is that fire stop is rarely installed exactly as mandated in the requirements of a UL system, which makes the installation non-compliant. For example, maybe the system that you're planning to use is tested only for a 1-hour wall, but your wall has a 2-hour rating. Unintentionally, installing this system would reduce the rating of the entire wall to 1 hour. Or perhaps you want to fire stop a 3-inch diameter bundle of low voltage cables, but the system you're planning to use is tested only up to 2-inch in diameter, which would also be non-compliant. Other common variables that must be considered are hole size, pipe diameter and material, insulation type and thickness, cable type and load. Each of these variables can behave very differently in a fire, and close attention is needed to ensure that the fire stop is installed per the requirements of a tested system. If the installation is to be code compliant, an as-built condition must be fire stopped in one of 3 ways. Either choose a fire stop system that has coverage for your condition, or alter your as-built condition until it conforms to the requirements of a tested system. Or, in the case of unusual penetrations, you can contact the manufacturer and request an engineering judgment. The point is that no fire stop should ever be installed without a UL system or an engineering judgment to defend your work. And even then, great care is needed to ensure that the installation matches the system requirements precisely. To help address most every condition that you will encounter, the UL Fire Resistance Directory contains more than 2,000 listed systems, which quite understandably can be a bit overwhelming. But there is good news. When the number of UL systems is broken down by craft, the number becomes manageable. A plumber, for example, typically needs less than a dozen UL systems to address nearly all plumbing penetrations. Therefore, by standardizing on a few UL systems, installation, system selection, and inspection of completed work is dramatically simplified. Proper FireStop application starts with trained installers who comprehend the importance of precisely following the installation requirements mandated in the UL system information. By following these procedures, your installations will be compliant and you'll be doing your part to help raise the standards of installing FireStop.